Hi, my name is Jason Schleifer and welcome to the first part of the four-part masterclass series, Animator-Friendly Rigging. This course was intended to teach you not just the 1-2-3 step approach to how to create a bipedal character rig, but to teach you how to analyze a problem, figure out the best solution for you and for your animators, and then implement it in a way that makes sense, is consistent, easy to work with, and kind of fun as well. The course comes with a ton of documentation. It's got probably about 1,500 pages worth of documentation, a whole bunch of mouse scripts, I think over 45 of them or something like that. And if you need any help, you can go to my website, http:/johnandhisdog.com. It's in the docs. So let's go ahead and get started.
Okay, so let's go ahead and get started with animator-friendly rigging. Just to kind of go over everything again, this first part of the course is going to focus on an introduction to rigging. What is it? Who does it? Why is it important? What are the guidelines for developing animation rigs, and how to go about actually developing your very first animation rig. For those of you who are introductionary riggers or beginning riggers, this should be a very good introduction to you. It won't be too complicated. It'll go over mostly theory and then get a little bit into Maya and how to use it to develop a very simple rig. For those of you who are more advanced riggers, this should be a very good refresher course and actually teach you hopefully some things that you may not already know about Maya, and also kind of get you into the process of thinking about rigging in a way that is going to make it easier for you to create more complicated rigs in the future. Part 2 of the course will go into biped rigs, and we'll look at the torso and the head and neck of a specific character. What we're going to do is look at some video reference. We'll figure out what the best controls are. We'll analyze those controls, figure out why they're the best controls for a given situation, and then look at various ways of implementing them. We'll do the same thing in part 3 when we look at the arms and fingers. We'll have arms with FK and IK, switching, some stretchy arms, being able to split joints for better skinning. We're also going to look at locking the elbow down and doing an FK and IK elbow lock arm. And on the fingers, we'll look at FK and IK finger controls, figure out the best solution for those, and also allow you to do things like put weight on the palms of the hands and stuff like that. Part 4, we'll go ahead and take a look at the feet and legs, come up with a good foot rocker system, and also take a look at how to create snapping controls for FK and IK snapping, mirroring so you can know which controls to mirror on the left and right side, how to mirror them, what the best solution is for that, and also how to go ahead and create a very simple UI and how to present things to the animators in a way that makes sense and is easy to use. Okay, so let's go ahead and get started with part 1, where we look at what is animation rigging. So what is animation rigging? Well, animation rigging is the process by which a character or an object is made ready for animation. What that means is that you as a rigger are responsible for making sure that whatever the animator is going to be picking up and moving and interacting with in their scene, you have to make sure that they have the ability to do that, and it's done in a way that's easy for them to work with. This includes props, any effects that happen, or any characters in the scene, anything that the animator can possibly touch. It's your responsibility to make sure that it's done in a way that is easy for them to use. So an animation rigger can be compared to, for example, a marionette maker. Now, if you all don't know, a marionette is basically a puppet that's in the real world, not in our little 3D world, but in real life. And this puppet has little strings attached to the head and to the hands and to the feet, and those strings are attached to pieces of wood. What happens is the marionette maker will create this puppet, attach the strings to the wood and attach the strings to the hands and feet and head, and then hand that to a puppeteer. The puppeteer will grab the wood, shake it around, and cause the puppet or the marionette to dance. So in this case, the animation rigger is the marionette maker, and the animator is the puppeteer. So it's the marionette maker's job to make sure that when the animator lifts up the piece of wood that's attached to the hand, it lifts up the hand. They don't want it to drop the hand or have the hand spin around like crazy. You want to make an interface for the puppeteer that makes sense and is easy to use. You can also compare a rigger to a hardware manufacturer. For example, let's say I build hammers, and my job is to create the best hammers in the world. So I use tools to develop materials to make these hammers. For example, I make steel and I make a wood handle and I create the best looking hammer in the world. I write a document explaining how to use the hammer to hammer in nails, and I give that to the person using the hammer to hammer nails into the wall. It's a very, very simple example, but basically you create a tool, you give it to the person, you make sure they understand how to use that tool. That's where animation riggers are similar to hardware manufacturers. Animation riggers are also superheroes. Because your job is to create something that animators are going to be using basically 10 to 15 to 16 to 20 hours a day in and day out, 5 to 7 days a week. If you make something that's easy for them to use and is fun to use, they will love you. They will consider you their best friend. They'll invite you out to dinner. They'll send you Christmas cards or Hanukkah cards or Kwanzaa cards or whatever it is that makes you happy. They will do it for you because they will love the fact that you made their lives easy. If you ignore their needs and you make their lives difficult and you make it so that when they grab something and try and move it, it instead sits down or spins or breaks or does something wrong, they will curse your name. They will hate you. They will be like, why did we hire that person? Gah! So if you do a good job, they will love you and you will be their own personal superhero, and you will have to wear tights and a cape. A bad animation rig. So what is a bad animation rig? Well, a bad animation rig is one that has confusing interaction. What that means is if I grab the hand of my character and I pull it to the left and it moves to the right, that's confusing. That's not doing what I'm expecting. So in that case, that's a bad animation rig. Difficult to find controls. If I go to try and move the head and I can't figure out how to move the head, that's bad. That immediately takes me out of the state of animating where I'm just cruising and I'm making things move, and all of a sudden I have to think about where to find stuff, or I can't find the thing that I'm looking for. That's a bad animation rig. If the animator has to think more about the technology than the art, that's a bad rig. Now, computer graphics is hard. It's difficult to animate, and right now, where we are in the current state of the industry, you do have to spend quite a bit of time thinking about the technology behind what you're doing. But if you have to do that more than necessary, if the animator has to literally leave the act of acting and leave that state of their brain in order to go, okay, well, I want to pick the left arm, so I have to do Control F9, 7 elbow hit to the screen. Okay, search for left L. You know, and they have to start typing, or they have to do anything that is more difficult than it needs to be. That's a bad animation rig. A bad animation rig is also medically damaging, both physically, can give people RSI, and mentally, they can go postal. If in order to move something, I have to hold down too many key combinations or do something else that physically hurts, that's bad. You should try and make a rig that is the least painful as possible. And something I recommend doing here is actually watching people use the rig. If you find they're clicking in too many places or doing too many things in order to select something, then you can see that this can be potentially physically damaging. So what if those are bad things, what's a good animation rig? Well, a good animation rig is easy to use. One that when animators look at it, they grab it and they move it and it makes sense to them. That's a very good thing. That's an awesome thing. It's consistent behavior. If I grab the left arm and I translate it up and it moves up, and I grab the right arm and I translate it up and it moves up, that's consistent. If I grab one and it moves up and one and it moves down, inconsistent. So we want to look for consistent behavior across different parts of the character and also across different characters. We want to make sure that the animator has the control that they need. If they need to animate the tail and you provide one single control at the base of the tail to move the entire thing, and they need to actually make it look, sinewy and kind of snaky and have overlapping animation, that's not the control they need. So you want to make sure they've got the controls they need to do what they need to do, and only the controls they need to do what they need to do. You don't need to over provide for the animator. That just gets confusing. You want a rig that's fast and interactive. The faster that the animator works, the better, because then they can try different things and they can stay in the moment of animating. And you want to make sure you provide the right amount of detail at the right time. If I'm blocking out my animation and all I care about is where the character is in space, what the arms are doing, and making sure the feet don't look silly, I don't need to see an entire high-res, super detailed model of the character's tongue and teeth. That's just too much information, and it'll slow things down and it'll be distracting. So you want the animator to only see what they need at a given time and to allow them to control what they see at a given time. We'll get more into that later. And also allow the animators to do their job without compromising their ideas. Animation is hard enough without having to compromise your acting choices based on what the rig is able or not able to do. So when you're sitting there trying to come up with the best way for a character to be, blah, blah, do whatever it is that they need to do and think, and you have to say, well, I can't do that because I can't lift the arm this high. Or I can't make this acting choice, which is going to be the best choice because when I bend the head forward, the chin intersects the chest and it blows up, and he ends up with a huge boil on his neck. That's a bad rig. You want to make sure the animator can get the acting across that they need without having to change their acting ideas just because the rig can't do something. So those are a lot of things that the rig needs to do to be good and what it can't do to be bad. So a good rigger will balance, one, the performance requirements of the character or prop. Every character has a certain number of requirements that are necessary. So not every single character has to be able to act full screen, with their face fitting a 30-foot screen in a movie theater. Many characters will be in the background and never be seen. Many times you'll have a character who might seem to need a whole bunch of controls, but they actually won't need them because those situations that they might use them won't ever be present. For example, let's say you have a huge dragon that needs to be able to flap its wings and fly, and you think that it would be really cool to develop a flame system where the dragon's going to shoot fire out of its mouth, and if it does, you want to make sure that when you look inside the mouth, you can see the little, whatever biological things that cause the fire to happen. You want to be able to see that go on. So you develop this entirely cool system that the animator turns on flame, and this stuff reacts automatically and does all this cool thing to shoot fire out. And then you spend months developing this, and then the director goes, oh, we're never going to have any camera shots looking inside the dragon's mouth. We don't really care about that. You've just wasted time. So really, a good rigger, you'll look at what the performance requirements are, and you'll make sure that they only solve those things. Any extra time you spend developing stuff that isn't going to be seen is time you could have spent making what is going to be seen better. You're also going to balance the manipulation and interaction needs of the animator. Now, sometimes the performance requirements of the character and what the animator wants and how they want to use it are going to be contradictory. So it's up to you to look at those two different situations and say, okay, well, which is more important, and balance it. And of course, being an animator, I would say that the animator's needs always outweigh the performance needs. But hey, that's my choice. And of course, the technical requirements of the character or prop. You need to make sure that you understand what technically is going to need to happen in order to get the character to do what it needs to do. And if those technical requirements or the performance requirements or whatever it is are going to inhibit the animator or make it so the animator can't make certain choices, you need to make that clear to the animator so they understand why there are certain limitations or restrictions. It's okay if there are, the animator just needs to know why. So what are the actual steps to creating the ultimate animation rig? These are steps I always follow when creating a rigging situation, or when I'm trying to create a rig, and they've come in really, really handy. The first thing that I like to do is I analyze the problem. I figure out what it is that I need to do, and I think about it, and I analyze it, and I overanalyze it, and I make sure I understand it. Then I'm going to go ahead and test possible solutions. This is kind of like the practice period. If you are a virtuoso piano player and you're about to go give a concert, you will at least probably play the piece once before you go and play it to hundreds of thousands of people. That's if you're like in the top 0.001 percentile of piano players. For the rest of you, piano players, you will go and you will practice the piece over and over and over and over and over again before you go and present it to the world. I think you should do the same thing when you're rigging. Because your rig is going to be used by however many animators for, let's say you've got 30 animators on your team, and those 30 animators are going to be working on a project for a year. They're going to be using that rig every day, 5 days a week, 10 hours a day for an entire year. So before you just go ahead and give them something that you haven't tried, go ahead and practice rigging for it first. Create a few FK-IK rig arms situations and practice using them and make sure that they solve the problem before you hand it off to them. Then you're going to analyze the solution. So you've analyzed the problem, you've tried a bunch of different solutions, then look at the solutions you've come up with and take a look and figure out if they actually solve the problem. Make sure that they do the right thing, make sure they're as fast as possible, make sure that they're solving everything that's necessary. Then go ahead and recreate the solution from scratch. I've seen many rigs where people just sort of start creating stuff, they create a rig, and there's all sorts of dirty nodes in there. There's like extra expressions and blank utility nodes and all sorts of stuff sitting in the scene that the animator doesn't need to see and they really don't want to have in there. So once you've figured out the solution, recreate it from scratch on the character, and then if you're into coding, I would say recreate the solution again using Mel scripting or MaxScript or whatever software you're using. Recreate it from scratch using code so you can go back in and change it again later if you need to. Much easier than having to go and recreate it all. So, how do you develop an animator-friendly rig, and how to make the best friend, or how to make the animator your best friend in the world, because they will look at you with this expression on their face. They will be like, "Oh, you are such a hero to me. Oh, you're awesome." Ah. So here's some of the developing guidelines that'll help make you the animator's best friend ever. And by ever I mean ever. You know, total BFF. The animation requirements. You need to analyze what the character, or basically how the character should act and what it needs to be able to do. These are animation requirements. These are things like, does the dragon need to fly? Does the slug need to be able to use its tail to propel itself, or is it just going to slowly kind of slither along? And rig requirements. Standard animation rig specs. Make sure that your naming requirements are the same. Make sure that your joint orientations are correct. Make sure that the naming of everything is the same. Make sure that your icons that characters are, or that animators are selecting are all consistent. These are things to help make sure that your rigs are consistent, easy for you to understand, and easy for the animator to work with. So let's take a look at our first example of how to actually use these situations and these requirements to create the bouncing ball. Now, why did I choose a bouncing ball? Every animator, when they start animating in an animation package, basically does the bouncing ball. This has happened for 3D animation. This is for 2D animation. This is most animators, when they start out, they will start doing a bouncing ball. So why not start creating a rig, or start rigging by creating a bouncing ball rig? Kind of makes sense, doesn't it? If that's what they're going to start with, this is what you should start with, because your job is to make them happy. And in return, their job is to be very happy by you making them happy. Haha. So how do you go about creating a bouncing ball rig? Well, if I were to say to any rigger out there, go ahead and create a bouncing ball rig, you probably have 150 different types of bouncing ball rigs created. And so what we want to do is actually analyze what's necessary when creating a bouncy ball and figure out what the best solution is. So how do you do that? The first thing we're going to do, this is rules number 1, 2, 3, 4, and number 27, is you need to get some reference.
Alright, so I don't have a ball on me that we can use to bounce except for this little baby ball here. This is from a little girl. Doesn't actually bounce and squash very much, but we can use it as an example. Now, I know shooting reference of yourself is extremely embarrassing, but you gotta do it. Every animator will go out, well, not every animator, but most animators will go out with a video camera and shoot themselves doing various actions in order to really understand how their body moves. Unless you are incredibly intuitive, you have no idea what your body's going to do when you go to start doing something. So, if you're going to be providing rigs for your animators, you need to go out and shoot reference yourself so you understand what it is that they're going to be wanting to get. So we can take this ball and we can figure out what it is that's absolutely necessary for us to do with it.
So we've got reference. What's the first thing the ball needs to do? Well, as you're moving the ball around, you will see the first thing that it needs to do is it needs to be able to move. We're moving the ball, it's got to move. So it seems pretty simple and straightforward, but you'd be surprised. You can't really make a bouncy ball rig without the ball being able to move around. It also needs to be able to stretch. Now, a lot of this is because you want to be able to squash the ball down when it hits the ground and does contact there, but also depending on the type of ball it is, in this case it's going to be a stretchy bouncy ball, you want to make sure that when the ball leaves the ground it can stretch and bounce around. The stretching needs to be angled because the ball is going to be moving not just straight up and down, but it's going to be moving horizontally. If you don't angle the stretch and the squash as the ball's leaving, it's going to look very, very funny. And the ball should be able to squash against any obstacle. We can't just look at the ground and say the ball needs to squash only this way. If it's going to bounce off the wall, it's got to be able to squash that way. And finally, or not finally, sorry, the ball also needs to be able to rotate. Very rarely will you have a situation where the ball is not going to have some sort of texture. So you want to make sure the animator can rotate the ball in some way. And the rotation should also be independent of the squash and stretch. For example, in A over here, notice how the rotation is twisting backwards in order to squash down correctly, and then it goes forward, and then it rotates backwards again, and like this. Whereas in B, the ball's continually rotating forward, which is what you really want. So the ball needs to rotate independent of the stretching. So we've got some basic rig requirements. We know our animation requirements now, but here are the rig requirements for what the ball needs to do. We need to have simple controls. We want to make sure that the animation is easily transferable between this version of the ball, another rig version, etc. We need to make sure the controls are unique and understandable for the animators. We want the controls to have correct rotation orders, and the controls need to be named correctly and have limited key ability. I will get into each of these individual things in a lot more detail in a few simple moments. We also have full rig requirements. So these are individual animation control requirements. This is the full rig requirement, meaning the scene that we give to the animators. It's got to have limited selection, meaning the animator can only select what we want them to. It has to be a clean scene that we don't have to worry about the animators selecting things we don't want them to. And the rig needs to be able to be moved anywhere within our entire scene. So what we're going to do now is actually analyze all of these problems. You can see the ball needs to move, has to have squash and stretch. Squash and stretch can be angled. We can squash against any object. The ball rotates, and the rotation, squash, and stretch need to be independent. Before we actually go and just create a ball rig, we're going to analyze each of these things and try and come up with the best solution. Now this is very, very important because we want to make sure that we have the best solution for each of these and they all work well together. Because we're going to be doing this, it makes a lot of sense to have one ball that we're going to be working with that we can keep loading up and trying different things. Again, we're not creating the final rig here yet. We're analyzing various problems and trying out different solutions before we go and create the final ball rig solution. So if we're going to go ahead and start going with the ball moves around, it makes sense to have a ball that we're going to be working with all the time, right? So to do that, what I'm going to do is I'm actually going to create a library to work with where I can save the ball. Okay, so let's go ahead and just create a new library in here, or new folder, and we'll call that library. Ta-da! So we have a library right there, and inside that library, we'll just create a folder, and we'll call it objects. There we go. So what we're going to do is we're just going to place all of our stuff inside, or place our ball inside the library object, so we can always get back to it if we need to. Now we're going to go ahead and go into Maya, and we're actually going to create a ball to work with. So we'll just go create NURBS primitives sphere, and there we go. We've got our little NURBS sphere here for all of us to look at. And because we know that we're going to need to rotate the sphere at some point, we'll just go ahead and create a texture for it. But before I do, you can notice right now that the sphere's name is NURBS sphere 1. It's very important to make sure that you name things correctly, and you always name them correctly right away. So I'm going to call this ball_geo. You can use any type of naming scheme that you want. I like to use underscore and then the type of object, just because it's a lot easier for me to remember. And I like doing it immediately as soon as I create the object so that I don't end up with sphere 1, sphere 2, sphere 3, sphere 47, sphere 292, and I don't know what's what. Okay, so we're going to go ahead and now apply that texture. So I'll go to Animation, Rendering, and this is going to be a very, very simple texture. We'll go to Texture, where is it? Lighting and Shading, there we go. Assign New Material, Lambert, which will assign a new Lambert material to our actual ball object itself. Once that's created, we will go ahead and change the name of the ball shader. Let's go ahead and change the name of this Lambert so we know exactly what it is. And we're going to call it ball_shader. See, we've got ball geo and we've got ball shader. Now we know that this thing is connected. Makes it much, much easier. Let's go ahead and actually add a ramp texture to the color. So I'm going to simply I'll simply click on this texture here, on this little icon, to create a ramp texture. When the window pops up, we'll click on ramp, and then we'll rename the ramp texture and the actual placement node so that we can find these easier as well. So we'll call this ball underscore text because it's a texture, and ramp just so I know what it is by looking at it. And we'll look at the place 2D texture node, and then we'll rename this as well. And this one will be named ball text place 2D, like that. Now what I want to do is actually go back to the ramp texture, and I want to change the shader a little bit so it looks just like two colors and they kind of repeat a whole bunch of times. So to do that, I'm going to delete that texture color right there. Let's go ahead and hit 6 so we can actually see what this texture looks like. And then we're going to move the blue bar down to be about halfway, like that, so that the texture only has these two colors. And we can see it's just those two. Then what we'll do is we'll switch the interpolation to none, like that, and you can see that we've got a blue and red ball. You can move this down a little bit more, halfway, or you could even type in an exact value down in here in the selected position if you want. But what we actually want to do is repeat this so the ball appears to be striped. So we can do that by going over into our 2D texture placement node. And we'll set the U and V repeat to 1, and we'll just change this to 5. And now you can see that the texture repeats itself a whole bunch of times, just like that. Now personally, I'm not a huge fan of these two colors. I think we can make something that looks a little bit nicer. So we'll just go back over here to our colors, and we'll choose new colors here for the textures. And I'm just going to go ahead and choose kind of a light blue color for the blue there. And we'll go back to our red. And let's choose maybe some sort of orangey kind of color. Something like that. Might be kind of nice. Okay, so we've got our colors, we've got our ramp texture, and we've got a rough ball. Let's go ahead and save this scene so we can use it later. So we'll just go to File, Save Scene As, and we'll go ahead and navigate to the location of where that file is located. Our animation friendly rigging part 1, we'll go to the library, in objects, and we're just going to call it ball, and we're going to change from Maya binary to Maya ASCII. Now the reason for this is mainly because an ASCII file is in text mode and binary is binary, so you don't actually have the ability to edit it. I usually like to save my scenes in ASCII just in case something breaks, so I can always go in and start modifying the file if absolutely necessary. It's a larger file size, but disk space is cheap and frustration is not. So there we go, we'll go ahead and save it like that, and now we've got an object that we can use over and over again for testing, and we can start checking to see if we can develop a rig that is going to solve all the problems that we have. Okay, so let's go ahead and start by looking at our first problem that we have, which is the ball moves around. We'll go ahead and switch over to Maya, and what we're going to do is just open up our ball scene. I like to make sure that this is always the first thing we do. Open it up, keep the scene clean just in case there's extra stuff in here that I created that I didn't know about. We'll choose ball. And then when Maya asks, we will tell it, no, do not save. Alright, so we've got our ball in our scene. Now our first requirement is to make sure that it can move around. So what's the easiest way to make the ball move? My opinion, select it, choose the move tool, and move it. Voila! We've got easy ball moving around. Very exciting. Animation rigging is so easy. Woohoo! We've solved the first problem, haven't we? Ball moves around. Can't get any more simple than that. Click it, grab it, move it. Super simple. Alright, now we must move on to option number, or control requirement number 2, which is that the animation is easily transferable. So what does it mean to say that what does it mean to say that the animation is easily transferable? Basically what will happen is as you're rigging and as you're developing rigs, the modeling department will still be creating models while you're working on your rigs. So at some point you will have to update your rig with the latest models. In this case, we are actually animating on the ball geo itself. So if the modeling department goes in and says, hey, you know what? We're going to change the name to Big Ball Geo or Beach Ball Geo, or we've got an actual new rig which is going to be our new name for the geometry, which is going to be totally more exciting than Ball Geo, but it's going to be Super Duper Ball Geo. When the animator brings that into their scene, it's going to break everything. So it's up to you to make sure that this doesn't happen. So instead of just making it so that the animation is on the object itself, it makes more sense to create a control that's always going to be named the same that you have control over. Then the animator animates that. And then if the modeling department changes the name of something, you can make sure that everything is connected okay and not disrupt the animator's flow. So how do we go about doing that? Well, if we just go create locator, for example, we can go into wireframe mode here, and you can see the locator, which has been created right in the middle of the scene. We can use this locator to control the ball itself. So I'll select the locator, select the ball, we'll choose constrain parent. And what that means is we're going to create a parent constraint, meaning that the locator will control the ball as if it is the parent of the ball itself, even though it's not. And now if I select that locator, and we go into shaded mode, and I move the locator around, you'll see that it's going to move the ball. The nice thing about this is if the ball changes, all we need to do is recreate that constraint, and everything works totally fine. The animator has no idea because when they save keyframes, they're keying the locator itself, not the ball. So what we've done is we've made sure the animation is easily transferable. Problem number 2 solved. Great. What about problem number 3? Controls should be unique and understandable. Well, I'm looking at the ball right now, and I look at this locator when I go into wireframe mode, and it looks just kind of like this thing that's out in space. If I have 20 different controls on my character, and they're all locators, I'm not going to know what object to select to do what. If the left arm looks like this, and the right foot looks like this, how do I know which one to pick? If they're overlapping each other, I'm going to have no idea which locator is what. So what we want to do is actually create a control that makes sense to the animator and is easy for them to understand what's going on. In this case, a locator is not it. So we'll do what's called iconic representation. We'll create something that represents what it is the animator needs to do with that object. So to do that, I'm going to delete the locator. And I'm just going to go ahead and take a look at the front view here. And so we've got our sphere. And what we want to do is create an icon that's going to represent motion. Well, notice with the mouse, when I go ahead and I pan and move around, you see what the mouse does? It turns in a little bunch of arrows there. We can create that for the ball, so the animator knows that that means they're going to be moving a ball around. So what we'll do is we'll go to Create CP Curve Tool, and we're going to click on the option box. Now when we do that, that's going to bring up the tool settings right here for the EP curve tool, and you'll notice that we're set to 1 linear. That means that every time I click, it's going to create a linear curve between those points. So we'll delete that, and let's create an arrow around the ball. Go back into the curve tool, and I'm just going to hold down X for grid snap, or you can click right up here, snap to grids, and I'll click here, then there, and then there. And you can really create whatever type of icon you want. It doesn't matter. The most important thing is to create something that makes sense to the animators. So go ahead before you start creating icons for your controls, ask the animator what type of thing makes sense to them. Do arrows make sense? Would a little squiggly mark make sense? Would a picture of the Mona Lisa make sense? Whatever it is that makes sense to them to represent movement, that's what you should be using. There's no 100% answer because all animators are different. But for me, personally, I think creating a curve that looks like an arrow makes sense for motion. So I'm going to select this, and I'm just going to scale it down to try and get it to fit around our ball a little bit better. So like that. And now if we take a look at our perspective view, and go into shaded mode, there you can see we have a curve that represents motion. So I know when I'm an animator and I look at this, if I pick it and start moving it, it's going to represent motion. If there was maybe an arc, I would think, oh, that might represent rotation. You know, it's up to you, really. So talk to your animators, figure out what they like, but then start making iconic types of controls that make sense to them. Now, we might be using this again, so what we want to do, instead of just recreating this every single time we need to do it, just like how we created a library for the ball, we're going to create a library for icons. So we'll choose Export Selection, so we can export this icon into our library. We'll go in here to our actual directory that we want, so we'll look to Desktop, Animation Presentation, Part 1, and you can put this wherever you like. Library, and in here we're going to create a new folder. We'll call this Icons, like that, and inside there we'll just go ahead and save this as, say, arrow.ma, like that, and there we go. We've got an arrow, and now what we want to do is make sure it actually controls the ball. So we'll select the arrow, select the ball, choose, again, Constrain Parent, and now when we pick the arrow and move it, it'll move the ball around. So we've just solved problem number 3. Controls should be unique and understandable. The next step of what we're going to look at is making sure the controls have the correct rotation orders. Well, unfortunately, fortunately, at this point, we don't really need to worry about that because this control is for the motion of the ball. Notice this is for ball moves around. We're not dealing with rotation. So it doesn't really matter whether or not we take a look at rotation orders. We'll get to that later, but for now, we can just say we solved that problem because we don't have to worry about it. We're just dealing with rotation. Woohoo! So our next step that we need to look at is the controls are being named correctly. Let's take a look at our Maya scene. So here we are in Maya. Let's see what is our control named. If we take a look at our outliner, you can see we've got ball_geo, which is the correct name. We've also got curve1. This doesn't make any sense. First of all, curve1 is not what we're controlling. What we want to really be doing is controlling the ball itself, and we want the animator to know that when they select this thing, they're controlling the ball. And second of all, curve1 tells us nothing about what it is this object does. We want to be able to look at the name of it and know, just like how we know this is the ball geometry, we need to know that this is the ball animation control. So what do? Well, we can change the name to ball_anim.